Let's look at OpenStax College Physics Chapter 25, Problem 58. A shopper standing 3 meters from a convex security mirror sees his image with a magnification of 0.25. Where is the image? What is the focal length of the mirror? And what is its radius of curvature? So let's start out by writing our knowns. So we are told that the shopper is standing 3 meters from a convex security mirror. Obviously, the shopper is going to be standing in front of the mirror, so that means that the shopper's image distance is 3 meters. We're told that it's a convex security mirror, so let's just jot down what this would look like. So here is the back of the mirror. The shopper is going to be somewhere here. That is the object distance of the shopper. Remember also that in mirrors, all of the distances in front of the mirror are positive, all of the distances behind the mirror are negative. So the object distance then of the shopper is plus 3 meters. Then we're told that the magnification is, M is 0.25. So the fact that the magnification is less than 1 means that the shopper appears smaller than his actual height in the mirror. But also the shopper is going to be right side up, so the magnification is positive. So those are the things that we know. The unknowns are where his image is formed, so that is the image distance. That's for part A. For part B, we're looking for the focal length of the mirror. And in part C, we want the radius of curvature. So there are two equations we can use for mirrors. One is 1 over f is 1 over do plus 1 over di. And the other one is the magnification equation, which is negative di over do. So we know the object distance and the magnification. So we can't use the first equation yet to solve for the image distance. That's what we want to solve for. But image distance appears in the second equation. We know object distance, we know magnification, so we can solve for image distance. So from here then, image distance is equal to negative magnification times do, and magnification is, so we have the negative sign, magnification is 0.25, and the object distance is 3 meters. And we end up with a magnification of, with a image distance of negative 0.75 meters. So let's stop and think. Does it make sense that we end up with a negative value for the image distance? Well, if we want the image to be upright, then we know that the image is going to be virtual, and virtual images are formed behind the mirror. Behind the mirror, the distances are negative. So we have a negative value here, meaning that the image is formed behind the mirror, and it is upright, so we have a positive magnification. So the value we obtained seems reasonable. Now we're looking for the focal length. So we have object distance and image distance, so we just use 1 over f is 1 over do plus 1 over di, and that is 1 over 3 meters plus 1 over negative 0.75 meters. If you do the math, multiply this, I'm just lazy, I'm going to multiply this by 0.75, multiply this by 3, and I end up with negative 2.25 divided by 2.25. So the focal length is negative 1 meter. All right, let's stop and think about that. So the fact that I get a negative value for the focal length, I messed up here. And I'll tell you why. So let's look at the negative value here. So the negative one is a focal length behind the mirror. And that makes sense because remember that the focal length is half the radius and the curvature is this way. So that means that I'm going to have an image, a spherical surface that has a radius on the negative side or the focal length of the negative side of the mirror. All right, so I said I messed up here. Why did I mess up? Because if I trace back my equation, I see that I have 1 over f is equal to this, right? So that means that it's not -1 meter. The 1 over f is -1 meter, but it is actually, let me change this, it's actually meter to the -1 because I found 1 over the focal length. So it turns out that actually the focal length is also -1 meter because 1 over 1 is just 1. So make sure that you pay attention to 1 over f's. You would have to flip that to get the correct value. Okay? All right, in part C, now we're looking for the radius of curvature. So remember that I said that this was the surface that the mirror was cut out of. It has a center here, it has a focal point there. We just solved for the focal point and said that that was -1 meter. So remember that the focal point is at the is right between, halfway in between the center of the curvature and the mirror itself. So then the radius is actually twice the focal length. So I'm going to leave it as twice -1 meter or -2 meters. And I'm leaving it as negative to show the fact that actually the mirror that we're dealing with has a radius of curvature that's on the other side of the mirror, that's not on the shiny side of the mirror, and that's what makes it negative.